So today I'm going to show you a product that we've been working on. Three of the founders of our company are architects. Christina's still licensed. She was also the first lead reviewer ever hired by the USGBC. So two of our founders have a deep passion in green buildings. And two of us were on the original Revit team, and then we also have a third person on the original Revit team in our support organization. The thing that we've come up with, Skema, is something where we literally think of it as a fast forward button for work that many people do in Revit. It wasn't, when I left Dassault Systems over a year ago, I worked at Dassault Systems for 10 years and did a lot of discussion around productizing and industrialized construction and DFMA and applying the Dassault Systems technologies to that. When I left a year ago, I wasn't thinking about actually starting a software company. I had become an owner of a commercial property in Massachusetts with a partner, and we started looking at what we could do, only to find out that there was a nonprofit that had bought up all the land around us, and so we proposed a partnership with them where we were going to do a whole lot of affordable housing and public space amenities and a whole bunch of program for this nonprofit. And since I just recently come out of the software world and there was all this interest from essentially people funding applications for developers to go make mass models and conceptual models with AI, I thought, well, let's try and apply that to this project. And probably to nobody's surprise here, those out-of-the-box things made for developers actually couldn't solve the problem that we were trying to solve, because we had a site that wasn't square, we had a parking podium, we ended up having a charrette with a partner of mine who was an architect and had done commercial property development, and another actual professional architect out of Boston. And after trying a number of software tools, we said, let's just do it in Rhino. So we ended up solving it in Rhino, and here's how we solved it. There was a couple. And it's a simple project, but this has been my litmus test project for Skema for a while, because it was just complicated enough that all the tools failed at solving it. Because we had a couple level parking structure that was on a site that wasn't square, so it had two structural grids meeting at a pivot point with a multi-height retail space in the corner, then with a public space amenity with apartment and fee simple townhouses on top of it. My partner in this had built a project like this a while ago in Alexandria, Virginia, and it was a good strategy for making public space where you have peek-through views on top of this podium. And of course, the apartment building is a double-loaded thing, but it's not parallel because the circulation space is not parallel, and half of it's outside. And so it was just one of these things where it was easier to just do something in a general tool. And so that kind of led to this idea of Skema, because we started applying these tools, and when we failed at it, we had done a Zoom call, and we sent the results of this Zoom call to the software developers, and we had one team come back to us that said, we think we can do what you're talking about. And so we discovered this team in Eastern Europe that had done a whole bunch of configurator prototypes for modular residential, parking garages, mass timber office buildings, but they had never productized any of this stuff. And having come from the original Revit startup and been at Autodesk for a number of years and Dassault for a number of years, I said, I think there's something here that's got an interesting big idea behind it if we think about it a little bit differently. And so we thought of this idea of taking this idea in Refabricating Architecture that was published in the early 2000s by Kieran and Timberlake, and doing a virtual version of it, where we literally take chunks of data sitting on people's servers for 5, 10, 15 years in Revit projects that they haven't been able to easily reapply. And so the idea is that we can use that as a parts bin, if you will, of things that you've already solved: a lab layout, a surgery suite, a apartment unit, and any type of thing in a program that has some repetition to it. We can systematize that process, and it's the benefits to it. I'm going to first talk about the business benefits of why you would do that, but let me first tell you what it is. So there's a conceptual side to Skema, and we had to call it AI, otherwise nobody would pay attention, but that's actually strictly true. When we first started this, it was completely procedural because it was a configurator, And in the last 8 months of working with architects to apply it to non-modular and non-residential building types, we've added 2 different forms of AI to it, and I'll describe what they are as I show you it. But mainly we have a conceptual side of this where we do context and massing and simulation for, sustainability. But really our secret sauce and the things that we want to be the best at is resolving the block and stack and doing the partie in these Jello cubes that you see. And while I'm going to show you simple geometric examples with the computational design crowd we have here, you're probably going to go, so what? The idea is, there's things that are done for form finding and then rationalizing that. We're on the rationalizing it side. So our goal is to be able to take any form you might come up with anywhere into this and be able to use the packing algorithms and the solvers to rationalize a program inside of it. We're understanding that it's an iterative process. And so one of the things I'm going to show you some work we've done with Thornton Tomasetti on also then deriving structural information out of this that uses Shapediver. And so part of what we see here is turning this environment, which is a design authoring environment, into a Grasshopper host. So you can take, for instance, facade scripts you've done and R generators and combine these things. But in a way that lowers the mere mortals threshold. So we've been doing workshops with principals at firms who they don't even use SketchUp, and 3 hours later they have a full building in Revit and they don't know how they got there, but the aha moments are pretty interesting. And part of the way they get there is that once we have the data in a block and stack like this, knowing the Revit chunks it came from, we can then reconstitute the building in Revit as if it had been designed from that way from the beginning. Except we can do it in about 45 seconds instead of a team doing it for 2 months. So why is that important? Well, none of the gray is showing up. So when you look at how an architect, from a business standpoint, goes after work, the AIA firm guidelines are go after a pipeline 3 times the size of what you actually need to keep the office afloat. So it's the 3-to-1 win ratio. Some firms have to go after 4 projects to win one. And you don't actually get to negotiate fee until you've actually won that. And then once you've negotiated a fee, you don't actually get paid until you get an army of people driving BIM software to go and make all those deliverables so that you can actually submit the invoices and get paid. And so what we've tried to do is shortcut this process so that we can take some of the knowledge from things that you don't need to reinvent and automate it so that you can take the repetitive drudgery part that you only need to tweak a little bit to make it unique to that project, so that we can essentially give you back maybe 30 to 40% of the fee that you negotiate, so you can either keep some of it as profit or spend it in other places like doing more interesting designs in the experiential part of the building, or more sustainability calculations that you don't have time for. However you want to spend that fee, that's our goal. But most of what we're trying to do is practical application of this technology to the current workflow with what's currently available. And then the payoff comes because we've got a very robust way of getting the data into Revit with the standards intact from the previous Revit projects. Now I say Revit, but it really is any BIM. Any BIM data can go into this, and we can take it out to any BIM platform, whether it's an Autodesk platform or some other platform. We're really agnostic about where it goes. We aren't built on any tech stack of any of the major vendors. We wrote this whole tech stack ourselves. We have a fondness for Revit, given that we have a lot of tribal knowledge about it, and so making good Revit data is kind of one of the things we're really proud of. But this is the kind of data that comes out from the system. What's interesting is that when architects use this, even if we had the same site with the same mass model, because of the way we harvest the Revit data into what we call a concept catalog, the outputs for both architects are going to be completely different, because one architect is going to have the way they lay things out with their logic and their wall families and their furniture, fixtures, equipment, light fixtures, all of those things. And the other architect is going to have what they use. So even though we've done a systemization of process, it does not systematize the results. The results are very familiar to you because they're based off the ingredients that you started with. And as a result, when I show this to you, you'll see that it looks like something you would make. And we'll show you a little bit more about the structure of the Revit data. So now this is going to be interesting because I have demos here, and I'm not exactly sure how to launch them with this. Is there? Okay, I'll do it with that then. All right, so do I see my cursor? No, I don't. Oh, okay, gotcha. Yeah, all right, there we go. So, let's see. All right, now maybe I can see that pointer, no? Yeah, I don't know that it'll, all right, well, I'm just gonna run through them in sequence. So, I will try not to stop them because I can't see the pointer. So, what we have is a neural network that helps us build the catalog. Now, what I'm showing you is another application of the same neural network that we have that's done for a 2D estimating application. What this particular implementation of this does, this neural network is trained to recognize space and adjacencies based on what are in those spaces. So this is doing that for doing a one-click takeoff of an entire PDF for an estimating application. But we use the same neural network to go into Revit data and say, oh, based on this door coming out of a corridor, this is a living room, these are bedrooms, that's a kitchen, this is a one-bedroom unit, or that's an operating table, these are equipment in this other room, that's a surgery suite. So right now, what we've been doing is mostly around residential because that's where this started. What we're coming out with next week takes these concepts and then applies them to non-modular buildings and non-residential buildings, and it just makes it more flexible. So let's see if I can keep moving here. All right, so the way that our application works is very similar to other conceptual design applications you've seen. The interface, say for Autodesk Forma or us or other conceptual applications, typically starts with a map. You sketch out a site. If you've got a sketch that you want to bring in and display to sketch over, or if you have a site survey, you can bring that in. But pretty much there's not a lot of differentiation on this side of things. We have some massing tools that, let's see if, can I start this? No, I can't start this. How do I get that to play? If I don't have a cursor. Yeah, I don't know. Clicking in it isn't helping. Yeah, it just goes to the next one. All right, so I won't be able to show you how we made the mass. Basically, yeah, that's too bad. I just don't have any way to play that, I don't think. Is there a way I can mirror the screen? That would make life a lot easier. We do just see a cursor?
Oh, there we go.
All right, maybe that'll do it.
It's above.
Oh, above, all right. All right, so some sketching tools that allow us to make, in this case, a podium. We've got some, and there's a free-form tool, which is how we made the podium. There's also something that's like a polyline where we can sort of add segments, change different parts and massing to it to give variation. But they're pretty simple tools, but the idea is you can take geometry in from other sources. That's where we're headed. It's a very early product. We first launched it at the AIA show in June, so it's only been around for a few months, so it's really early days. The idea is you can assign uses to various parts of the building, mix them on floors, and then we have analytics that track that. You can make multiple options, pretty much the things you're used to in this type of conceptual tool. Then we have some sustainability simulations. So for instance, we can look at sun hours. We can see that we're casting shadow on the adjacent building, so maybe we want to revise this. We can do some daylighting calculations. VSC is a daylighting measure in Europe, so we can see we're affecting the daylight of the adjacent building. We've also done an integration with Cove Tool, so we can take the geometry here, send it over to Cove Tool. They can do their interior daylighting analysis, and then we bring that back and display that here. Now, the reason that we've done this is that we think the future of what's going to happen is that there's a lot of potential platforms with people charging with toll booths, dues, and tokens, and things like that. we see ourselves as a cloud application. We run in a browser on any computer, and we integrate with other web applications through web services so that when we have a use case where we want to simplify it for a user, we just make that web services connection directly app to app, and we have eventually an ecosystem of connected apps that understand how to do a data-driven workflow without having to resort to files. That's sort of where we're coming from in producing this. The magic happens when we get to this block stack. So we start applying catalogs, and as you can see, some of them fill up this mass better than others because they're combinations of exiting core and the units. And then, for instance, we're changing the mix, so we got more orange units when we change it. Now when we change the mix, we'll get more purple units. Those represent the repetitive element in here, and we can drive that based on whatever our pro forma requirements are. I'm showing you an apartment building, but essentially this is how we're thinking about this for other types of projects that have some repetition to the program. It could be a medical office building, a clinic, school, anything like that. The last piece is then taking this and reconstituting what would be a Revit project had this been done this way in Revit. So the block stack cubes represent chunks of Revit data. When we click the LED 350 preview, we have a system called Schema BIM on the Amazon cloud that will go and take those cubes and calculate what the Revit data would look like for that cube from the data that we took from this particular project to make a concept catalog. If we chop the top off, you'll see everything's inside there. Stairs, furniture, kitchens, toilets, all of that stuff. Because whatever was in the Revit project is in here. So we have ceilings, they have light fixtures, air diffusers, all of that stuff. Likewise, the idea here is that we are not trying to make 100% building at a push of a button. So what I've shown you is the modular solution. So the modular solution is like a one-click solver, and it's rarely just implemented for apartment buildings today. Next week, it turns into something that's more interactive, which is how we apply it to other buildings. So as opposed to a one-click solve the whole building, you go to a floor, you lay out circulation, you lay out exiting, and then we fit the repetitive units around that. And there's functionality that then allows you to take a unit from a library that maybe isn't the same size as the space you have available and understands how to morph what you have into the shape that's available. That's done using a Google AI library to do that morphing. And that's one of the things as our next sort of big test with the architects. So we've got a healthcare charrette coming up with TVS next week. We've got a school charrette coming up 2 weeks after that. So we're testing out these other building types right now. Now the main thing is that the result of this is that the data flows into Revit. So let me see if I can figure out a way to start this one again. It's at the top. I'm not exactly sure how you did it. Yeah, okay, so down here, maybe. If I just click on it, maybe it'll do it. All right, so when the data goes into Revit, the units themselves are linked RVT files, and then inside them, anything that constitutes a module is a group. So if you take this from Revit and you open it up and you bind the links and explode the groups, then you just have a native editable Revit model as if you had drawn it in Revit from the beginning. However, people like to keep that structure intact because you can then still make changes in Revit. You can go into a unit, move some things around, and all of the units in the building will update. Or I can go into a group and say, oh, I don't want an exterior balcony condition, I want an inset balcony condition. I can just change that in the group and then it will update all the balconies everywhere. So part of the reason we've structured it this way is because we understand sort of what is good structure of data in Revit and how is it then flexible after it comes out of our system. So we don't think of ourselves as a collaboration platform, we just think of it as a fast forward button. Once we're done, you take what we've made and you can take it back into Revit if you want, you can take it into another BIM system, you can take it into Snaptrude, you can take it into Conic, wherever you want to take it, we're happy to have you take it there. One last thing we want to show is the integration that we've been working on with Thornton Tomasetti around, let's see, do we have a cursor yet? So just these block stack cubes, that's how we generate the architectural model. However, we can send those to a geometry service that then produces primary structure, because that's one of the differences about doing a modular project, right? Modular projects rely on the chassis of the module holding the building up, and so you have to stack them. Once we start doing non-modular projects, you need primary frames. So the nice part about this is that the way those Jello cube block stacks cubes are, they indicate to us where vertical support should be. And so we end up getting a coordinated model between the architectural and the structural this way. At least that's the theory. So I've shown you what is right now a demonstrator. We're hoping by AU you actually see that inside Schema. But it's a research project right now with R&D. Here's a few things that have been said about Schema, just so you can see the reaction. All the early architects that we've been working with, we go in and we do a project charrette. So typically what they'll do is we'll get a brief about an actual project that they're either pursuing or that we're doing in parallel, and we'll invite designers in to use Schema, and usually they've never seen it before. And at the end of a few hours, they have a building. Again, our goal is not to make 100% complete buildings, just the part that saves you the drudgery. So we think of it as the fastest way to get to 60% complete. And then after that, you take and do it however you wish, using your favorite processes. Mainly, what we get out of this is, first off, any of the data that we take into a concept catalog only ever stays with that architect. So inside Schema, there's a company object. Any accounts from your office are part of that company object, and the concept catalogs that we've made for that firm are only visible to the accounts within that firm. So that's part of what we do. We sign an NDA when we get the Revit data from people to do these workshops and these charrettes. There's a significant time savings. In our early work, basically it's been between 6 and 8 weeks. On residential projects, it's whether they have the units developed or not yet. An increase in quality and sustainability. Because we're working from designs you've already built, you've already field tested these layouts. And so there's a measure in manufacturing called the quality of first pass design, which really doesn't exist in AEC. But we believe that we can actually positively affect that quality of first pass design using this process, because we're systematizing things that have been successful. And we're not necessarily making that you're rubber stamping them. You're just using them as a basis for the formation of a new design. As I said, because we give you back some fee and you can choose to keep some of it, there's the potential for some pretty significant increases in project profitability. Because of the way it works as a conceptual design application, you can spend potentially much less effort winning work and possibly increase the win ratio, which would then also give you the ability to take on just more projects with the same headcount. So we think that gives anybody trying us out a significant first mover advantage. So with that, I'll just say thanks for having me here so I could explain Schema to you. There's a picture in the press release that we have. If you go to my LinkedIn profile, it's a pinned post, so you can see what the new version with more weird angles and strange things in there looks like in Schema coming up, and then we will be showing that starting next week when we launch it. Thanks very much.